These are the 3.3 notes. We actually split 3.3 into 2 days, and 3.3 is introducing function notation, which we talked about in class. Function notation, all that is when they replace y equals with f of x equals. So when they're using function notation, all they're telling you is what you're looking at is a function. So remember the last couple of weeks, we had to determine whether what we were looking at was a function by seeing if it passes the vertical line test or looking to see if any of those x values were repeating with different y values. Well, now they're going to use f of x instead of y equals, and that lets us know what we're looking at is a function. Okay? So the first example that I did with you guys in class, the instructions said evaluate f of x equals negative 4x plus 7 when x equals negative 2 and positive 2. Okay? So when they ask you to evaluate something, really all they're asking you to do is substitute in a value for a variable and then solve what's left. So in order to evaluate f of x equals negative 4x plus 7 when x is 2, they may write it like this and say f of 2 equals, and they're just telling you to evaluate the function when x is equal to 2. So here, all I'm going to do is I'm going to do negative 4 times 2 plus 7. So I'm just replacing the x value with 2, and then I'm going to do that computation. So I know that f of 2 is going to equal, well, negative 4 times 2 is negative 8, plus 7 is negative 1. Okay? Then if they wanted you to also evaluate the function when x is negative 2, then I'm going to find f of negative 2 by using that same equation. So negative 4 times, but this time I'm putting a negative 2 in for x, plus 7. So when I do that, and I'm just doing that computation once again, negative 4 times negative 2 is positive 8, and positive 8 plus 7 is 15. Okay? We also did these two examples in class, and if you have any questions about those, please come in and get extra help. So the next section that we talked about in class was what happens when they say for h of x equals 2/3 x minus 5, find the value of x for which h of x equals negative 7. So this is a little bit different than what they had us do on that first section, because now they're telling me h of x is negative 7. So we're going to replace h of x with negative 7, and we're actually solving for the x value this time. Whereas on the first one, they gave me x, and I was solving for y. Okay, so I am going to work this example with you guys. So I'm replacing h of x with negative 7, and then I still have the rule 2/3 x minus 5. Okay? So this looks like what we did the entire first chapter. It's just solving equations. So we're trying to get x by itself. So the opposite of subtracting 5 would be to add 5 from both sides, add 5 to both sides. Those would cancel. Negative 7 plus 5 is negative 2. I'm going to bring down my 2/3 x. Then the opposite of multiplying by 2/3 would be to divide. And remember, we reviewed how to divide fractions in your calculator. So if you were using your calculator, you would put in negative 2 divided by, and then you want to use parentheses. So you're going to open your parentheses and put in 2 divided by 3 in order to get that 2/3. This fraction is just a division problem. And then you're going to close those parentheses and hit enter. And when you do that, you find out that x is actually equal to negative 3 here. Okay? So that would be the answer to this one. I do want to do another one of these with you because this one you guys were a little unsure about. So let's go ahead and look at number 4. In this one, they're telling me that f of x is equal to 21. So I'm replacing f of x with 21, and then the function rule is still 6x plus 9. So in order to solve that for x, I'm going to subtract 9 from both sides. Those will cancel. And when you do 21 minus 9, you're going to get 12. you're going to bring down your 6x. The opposite of multiplying by 6 is to divide by 6. And when I do that, I'm going to find out that x is equal to 2, which is my answer. Okay, so the key here is that they are actually giving you the value for y, or f of x. So you're replacing that with the numerical value and solving for x this time. Okay? We spent a lot of time on this last section of the notes for today. Well, actually this was on Friday, but when we were looking at this, we talked about all the different ways that you guys know how to graph. We've actually done a lot of graphing, and you guys are doing a great job remembering the things that your 8th grade teachers taught you about graphs. So these are the things that we've reviewed so far. We've reviewed how to graph using our graphing calculator, which that one obviously is going to be the most efficient way if your equation is already solved for y. We also talked a lot about slope-intercept form. I've been talking to you guys about that for about a week now, and that's where we're actually moving. We're going to do more specific work with slope-intercept form coming up. And then I talked to you guys about just making a table of values. Okay, so these are the things that we also discussed, that you need at least 2 points in order to graph. We want to connect those 2 points using a straight line. You can use the edge of your paper or a straight edge in order to make sure that line is straight and your graph is accurate. And then also making sure that we extend our line all the way across our coordinate plane. So let's go ahead and look at our first example that says to graph f of x equals 2x plus 5. So the first thing that we need to review is obviously they're using that function notation because that was the focus of our notes on day 1. So f of x is the same thing as y equals. So this equation just says y equals 2x plus 5. So what we did in class, most of you guys used your graphing calculator, so I'm going to review that, but I'm also going to review slope-intercept form. So if you're using your graphing calculator, at the top of your notes it tells you how to do this. You're going to press y equals, and then you're going to enter the equation, which is 2x plus 5. Then after you do that, you're going to want to press second graph in order to view your table of values. Because remember, we need at least 2 points to graph. So the first point that I see on my table of values on my calculator is 0, 5. So I'm going to graph that. And that would occur right here at the top of my graph, and that is my y-intercept. Okay? Then the other point that I'm going to use is negative 1, 3, which would be about right there. Then you want to use something straight, which I'm going to have to eyeball this, but if you were graphing on your paper, hopefully you would use the edge of your paper or a straight edge in order to graph that line. Okay? Alright, so that's one way to graph. You could just use your graphing calculator. Okay? I'm going to review slope-intercept form using this equation because it's something that you guys remembered from 8th grade, and it's also something that we've been looking at. So remember when we talked about slope-intercept form, which is y equals mx plus b, we talked about the fact that the b value represents your y-intercept. The y-intercept is where your graph is touching the y-axis. In this case, my graph should be touching the y-axis at 5. And according to my table of values, which I used in order to graph, my y-intercept was 5, and that's why we put our first point there. Okay? So we didn't even need to use our calculator. We could have just looked at our equation and known to place our first point on 5. Okay? Then the next thing we talked about is that the number that's in front of x is called your slope. It's also called the rate of change, and that is the amount that the graph is going up or down by every single time from point to point. So if we started on our y-intercept, which is 5, and we went up 2 and over 1, we would be back on our line. And that would give us our second point, which we could draw our line through. The point we chose to use was negative 1, 3. And if I use my rate of change or my slope and I go up 2 and over 1, I am actually back on my line. That slope, or that constant rate of change of 2, is what creates a straight line to begin with. Remember when we were talking about determining whether or not something was linear, that's what we were looking for, that constant rate of change. Okay? So we did these two examples in class, but if you have questions about graphing, you need to come in and get some help. Alright, so that concludes our day 1 video. That is all that we covered on our first day, and we will pick up with day 2, which is applying all of these things to word problems in class tomorrow. You guys have a great night.